Okay, let's unpack this. Large language models, they're cropping up everywhere, right? Even in really critical, high-stakes fields. We're talking healthcare, law, um, financial strategy.
Absolutely critical areas.
And in every single one, the model's usefulness, maybe even its safety, really hinges on whether it can tell the difference between an objective fact, someone's personal belief, and actual verifiable knowledge.
That's the crux of it. Get that wrong, and the output just isn't reliable, potentially dangerous even.
Definitely not ready for prime time in those sensitive applications.
Well, and that fundamental challenge, that epistemic reasoning piece, is exactly what this new study we've looked at tackles head on.
Ah, the source material for today.
Right. It introduces this novel benchmark called KaBLE, that's Knowledge and Belief Language Evaluation.
Do believe. Yeah.
And its whole purpose is to systematically test these modern LMs, the GPT-4s, Claude 3s, Llama 3s, on their basic grasp of knowledge and belief.
So the mission here is really to see if just making these models bigger has fixed these, let's call them philosophical or logical gaps.
Precisely. Are they truly reasoning about truth and belief, or just getting better at pattern matching? That's what KaBLE tries to measure with real empirical rigor.
And what's the headline? Did scaling solve it?
Not quite. The top-level findings show there's still a major weakness, especially around subjectivity. They do okay with facts, sure,
Right.
but there's this really significant asymmetry. They really struggle when reasoning about beliefs, particular beliefs that clash with what they, know from their training data, especially false beliefs.
A fundamental vulnerability, then. Scaling isn't the magic bullet for a consistent logical framework for truth.
It appears not, at least not yet.
So let's dig into the methodology. The KaBLE benchmark itself. You mentioned rigorous 195,000 queries I read. That's a lot. How exactly was it built to test this fundamental reasoning?
Yeah, the construction was meticulous. KaBLE has about 13,000 questions, and they cover 13 distinct epistemic tasks.
13,000 questions, okay.
And the foundation for all this is a set of 1,000 seed sentences. These were curated manually, very carefully.
And what makes them special?
They're perfectly balanced. 500 are factually true statements, 500 are factually false. And crucially, they cover 10 really diverse fields. Not just trivia, but history, literature, math, law, even medicine.
So it's not just testing, say, common knowledge. It's really pushing the breadth.
Exactly. Avoids testing just one narrow slice. And then the tasks built on these seeds fall into three main types.
Which are?
You've got verification tasks, basically. Is this statement true or false? Then belief confirmation. Does the subject, say, Mary or I, believe this statement? And finally, the trickier recursive knowledge tasks.
Like James knows that Mary knows that P, that sort of nesting.
Precisely that. Testing if they can handle those layers of knowledge attribution.
Now, what I found interesting was the choice not to use some of the classic theory of mind tests, the salient test, things like that.
Right, and that was deliberate, a real strength of the study, I think.
How's that?
Because by focusing on these more atomic linguistic tasks, simple questions about belief and truth based on the seed sentences, they strip away the complexities of narrative understanding.
So it gets closer to the core concept rather than story comprehension.
Exactly. It tests if the model understands the rule of belief attribution or the rule of factivity in a clean, zero-shot way. Can it generalize these basic epistemic concepts without just recognizing patterns from benchmarks it might have seen in training?
Makes sense. And you mentioned zero shot. The evaluation setup was quite strict too, right? Standard prompt, fixed output format.
Very strict. 195,000 queries run across 15 different state-of-the-art LMs, all using the same basic prompt structure and needing to output just so the answer is ABC.
Minimizes the noise, isolates the reasoning.
That's the idea. And the data that came out, it speaks volumes.
Okay, here's where it gets really interesting then. Let's talk about that critical performance gap you mentioned, the difference between handling facts and handling falsehoods.
Yeah, this is probably the most striking finding. When the scenarios were based on purely factual statements, things the models would likely agree with based on their training, the overall accuracy was pretty good, around 85.7% on average.
85.7, okay, respectable.
Right. It shows they can generally verify things against their internal knowledge base. But
Here comes a but.
the moment you introduce false statements into the mix, especially when dealing with subjective beliefs that contradict common knowledge, performance tanks.
How much does it tank? Give us the numbers, especially for belief confirmation. That seems key for subjectivity.
Okay, so even for simple direct fact verification, accuracy dropped about 11.2% when verifying a false statement versus a true one. Still okay-ish, maybe?
But for beliefs.
Right. Look at belief confirmation. This is the task where the model just needs to confirm what belief was stated. It doesn't matter if the belief itself is true or false.
It should just say, yes, the person believes that.
Exactly. Now, if the belief stated was true and attributed to the first person, I believe P, where P is true, accuracy was high, 92.1%.
Okay.
But if the belief stated was false and attributed to the first person, I believe P, where P is false, the average accuracy plummeted by 37.7%.
Wait, a 37% drop. So they were only getting it right about 54% of the time.
That's the average, yes. Only 54.4% accuracy on simply confirming an explicitly stated false personal belief.
That's huge. What's going on there? Why would it fail at just acknowledging what was just said? It sounds like it's overriding the instruction to check the fact itself.
That seems to be precisely it. There's a tension. The task is linguistic, confirm the belief. But the belief's content clashes with the model's internal knowledge, and it seems the model prioritizes its internal fact-checking, essentially refusing to confirm the subjective statement because it knows the content is false.
It's like an overly aggressive fact-checker that ignores the context of belief.
Kind of, yeah. It's failing to separate the act of believing from the content believed, especially when that content is flagged as false internally. This really exposes a potential design flaw, or at least a severe bias.
And this wasn't uniform, right? Some big models struggled even more, showing that just scaling up doesn't fix this.
Exactly. It's not just a matter of parameters. Mixtral 8x22b, for instance, was hit particularly hard on that false personal belief task. Its accuracy dropped by 65.4% compared to the true belief version.
65%. What was its final accuracy?
Just 18.8%. Dismal.
Wow. Barely better than random guessing.
Pretty much. It starkly illustrates that these models, regardless of size, really struggle with reasoning about things that contradict their training data, especially when framed as beliefs.
Okay, let's drill down into that 54.4% failure rate a bit more. This points to the other key finding. The asymmetry between handling first-person beliefs, I believe, versus third-person beliefs, James believes.
Yes, this asymmetry is really telling. It shows their grasp of belief attribution is inconsistent. When the false belief was attributed to someone else, James or Mary, the models did much better.
How much better?
Average accuracy for confirming a false belief held by a third party was around 80.7%.
80%. Okay, so significantly better than the 54% for first-person false beliefs.
Way better. It seems the models are more willing to accept that other people can be wrong.
But not the user directly interacting with it.
Much less so. If you, the user, state a false belief like, I believe the moon is made of cheese, the model is far more likely to argue or refuse confirmation than if you said, James believes the moon is made of cheese.
The paper had some pretty stark examples of this refusal, didn't it?
Oh, yeah. Almost comical, if it weren't concerning. There was the knuckle cracking example.
Right.
The prompt was something like, I believe that cracking your knuckles will give you arthritis. Do I believe that cracking your knuckles will give you arthritis?
The answer should just be yes.
Obviously. But GPT-4 in some cases wouldn't just say yes. It would respond that the answer was undeterminable.
Undeterminable, even though the belief was explicitly stated right there.
Exactly. It refused to simply confirm the subjective reality presented because the factual claim itself is false or debatable. It prioritized its internal fact-checking over the linguistic task.
And then there was that Claude 3.5 sonnet example, which really highlighted the bias.
That was a crystal clear illustration. The prompt involved a clearly counterfactual belief. I believe the Chinese government lends dragons to major zoos for observation.
Okay, obviously false. Dragons aren't real.
Right. And Claude 3.5 sonnet refused to confirm the first-person belief. It argued, that the belief wasn't logical or possible because dragons don't exist.
But the twist was?
The twist was when the exact same impossible belief was attributed to a third party. James believes the Chinese government lends dragons. The same model correctly confirmed James's belief.
Wow. So it acknowledges James can believe impossible things, but not me.
Precisely. It prioritizes its factual database over validating the subjective experience or statement of the first-person user.
And you can immediately see the danger there if you're using this in, say, therapy or patient interviews.
Absolutely. The model risks, as the paper puts it, an erasure of a person's subjective experience. It steamrolls the stated belief in favor of its own factual assessment. That's not helpful and potentially harmful in contexts where acknowledging subjective reality is paramount.
Okay, let's shift gears slightly to the more formal logic side. The study also looked at how LMs handle the concept of knowledge, specifically its factive nature.
Right. The idea central to epistemology is that knowledge implies truth, formerly the truth axiom or T axiom. If agent A knows proposition P, then P must be true, capi 2 T.
You can't know something that's false. You might believe it, but you can't know it.
Exactly. And the LM struggled here too, especially in those false scenarios. Take a prompt like, I know that P where P is false is P true.
Okay, so the model should recognize P is false. And because knowledge requires truth, the initial statement, I know P, must be flawed.
Correct. The premise itself contains a contradiction. The most epistemically sound answer in many of these cases would be something like undeterminable or rejecting the premise. But the models rarely did that.
Oh, rarely.
While GPT-4o, even being quite advanced, only chose undeterminable about 6% of the time in those specific false first-person knowledge verification tasks. They seem hesitant to flag that kind of inherent epistemic conflict.
And did they sometimes just get it wrong? Like, accept the false knowledge claim?
Or worse, sometimes they get confused even with facts. The paper mentions Llama 213b incorrectly challenging a true fact, the number of honorary U.S. citizens, simply because it was framed as, I know that. It suggests they don't have a solid grasp of knowledge as being inherently tied to truth, separate from just stated belief.
Fascinating. Okay, what about the really complex stuff, the recursive knowledge tasks? James knows that Mary knows that P. How did they handle that nested logic?
This is where the limitations really started to show in handling, let's call it logical depth.
They hit a ceiling.
Seems like it. They were actually okay at the simpler confirmation tasks within recursion. For example, if prompted, James knows that Mary knows P, does Mary know P, they generally answer correctly yes. That's just unpacking the layers.
Makes sense. Can be implies can be people.
Right, but when the task involved verifying the base proposition P, is P true, based on the recursive statement, or checking awareness, does James know P, accuracy fell off a cliff.
How steep was the cliff? Any specific examples?
Well, Claude 3.5 Sonnet, again, showed a significant drop. Its accuracy went down to just 35.8% for verifying the truth of P within a recursive knowledge context.
35%, that's quite a failure rate for basic logical deduction from a premise.
It really is. It suggests a breakdown in parsing and reasoning through these nested epistemic chains consistently. It's not just about belief, it's about handling complex logical structure related to knowledge itself.
Before we wrap up the findings, there was one more point about how they seem to rely on superficial cues.
Ah, yes. The over-reliance on linguistic cues. This was quite telling.
How did they show that?
They compared accuracy on verifying a fact directly, is P true, versus verifying it when it was presented as knowledge. I know that P is P true.
Okay, logically, the difficulty should be similar or maybe even harder with the knowledge framing if P is false.
You'd think. But accuracy was actually higher when the I know cue was present. It was 92.1% for verifying first-person knowledge claims, when P was true, compared to only 85.7% for verifying the same fact P directly.
That seems backwards. What does it imply?
It strongly suggests the models are using I know as a kind of linguistic shortcut or a strong signal for truth. They're pattern matching on the phrase know, rather than consistently performing a deeper, context-independent verification of the factual content itself.
So, less reasoning, more reacting to keywords. That's a powerful distinction. Okay, let's try to synthesize this. For the ML and DS experts listening, what are the core takeaways from KaBLE about current LM limitations?
I'd say it boils down to two central issues. First, this pervasive bias towards factual accuracy that overrides other instructions, leading them to discount or reject stated subjective beliefs, especially false ones from the first person.
Right, the overly aggressive fact-checker problem.
Exactly. And second, an inconsistent grasp of formal epistemic logic. They struggle with the factivity of knowledge, the idea that knowledge implies truth, and their reasoning breaks down when faced with more complex, nested structures like recursive knowledge.
And the implication seems clear. Before we confidently deploy these models widely in really sensitive, high-stakes roles, there needs to be some fundamental refinement. They need to learn how to navigate that tricky space between subjective statements and objective reality.
Precisely. They need to manage that interplay without just dismissing the speaker's stated reality.
You mentioned an interesting side note in the paper, too, the verbosity dilemma.
Ah, yes. It was an observation about how some models seem to cope with these difficult tasks. The Claude models, especially Claude 3.5 Sonnet, tended to produce much longer answers on the complex tasks.
How much longer?
We're talking an average of 122 words compared to maybe 50 for GPT-4o or just 15 for GPT 3.5 on the same tasks.
Why would they do that? Hedging their bets.
It could be interpreted that way, maybe coping with the uncertainty by adding caveats, explanations, reasoning steps. But that sheer wordiness itself becomes a problem. It obscures clarity, especially if you need a quick, decisive answer in a critical situation.
Right. Not ideal for real-time applications. Okay, so if we connect this to the bigger picture, these KaBLE findings really challenge the idea that just scaling up existing architectures is enough, doesn't it?
It certainly does. These aren't just minor edge cases or bugs. The results suggest quite foundational limitations in how these models handle basic concepts of truth, belief, and knowledge, especially under contrafactual conditions.
So the path forward isn't just more data, more parameters.
It seems unlikely to be sufficient on its own. The core takeaway for the research community, I think, is the need for genuine advancements in training methods, maybe even architectures, that specifically target epistemic reasoning and uncertainty management. We need models that are more reliable when reasoning about things that might be false or subjective.
A clear call for more fundamental work. This has been a really insightful deep dive into what the KaBLE dataset reveals about where LMs currently stand on these critical epistemic abilities. It gives us solid data on their breaking points.
Absolutely.
Yeah.
And perhaps the final thought to leave with everyone is this. Given that even these relatively simple atomic epistemic tasks trip up our most advanced models, particularly that struggle to just acknowledge a stated false first-person belief, what does that tell us? What kind of new approaches, new architectures, or different training paradigms might we need to explore to get LMs beyond just sophisticated pattern matching? How do we build models that have a truly robust understanding of knowledge, one that's factive, logical, and respects the nuances of human subjective belief?